National Electrical Code Section 210.52 code addresses the use of 15 amp receptacles on 20 amp branch circuits. This section is applicable to both residential and commercial installations. The core principle is that a 15 amp receptacle is permitted on a 20 amp circuit as long as there are no specific loads connected to that circuit that mandate a 20 amp receptacle. The rationale behind this allowance is that many common electrical devices draw less than 15 amps. Therefore, using a 15 amp receptacle is adequate for these lower current devices. However, it is crucial to ensure that no equipment requiring a 20 amp plug or drawing a sustained current exceeding 15 amps is connected to such a circuit. In practical terms, this means you can install standard 15 amp duplex receptacles in a commercial office space fed by a 20 amp breaker. This is perfectly acceptable for powering computers, lamps, and other small appliances. But if you have specific equipment that requires a 20 amp circuit, such as a large microwave, a specialized tool, or any device with a 20 amp plug, that equipment needs to be connected to a dedicated 20 amp circuit with a 20 amp receptacle. It is imperative to consider the anticipated load on each circuit when designing an electrical system. A 20 amp circuit can handle a greater total load than a 15 amp circuit. However, overloading any circuit can lead to overheating, tripping the breaker, and potentially creating a fire hazard. The National Electrical Code provides detailed guidelines on calculating the allowable load on a circuit based on the conductor size, the breaker rating, and the type of occupancy. It is also essential to consider the deterring factors outlined in the National Electrical Code, especially when dealing with multiple conductors in a conduit or elevated ambient temperatures. These factors reduce the allowable ampacity of the conductors, and it's important to account for them to ensure the circuit operates safely and reliably. Also, when installing 15 amp receptacles on a 20 amp circuit, it is crucial to use appropriately rated wiring. The conductors must be rated for at least 20 amps to match the overcurrent protection provided by the 20 amp breaker. Using undersized wiring can lead to overheating and create a significant safety hazard. The most common wire sizes used for 20 amp circuits are 12 American wire gauge copper or equivalent. Always consult the National Electrical Code tables for the correct conductor size based on the ampacity, insulation type, and installation conditions. When deciding whether to use 15 amp receptacles on 20 amp circuits, it's also beneficial to consider future needs. If there's a possibility that higher current devices might be used in the future, it might be prudent to install 20 amp receptacles from the outset. This will avoid the need for future upgrades and ensure the electrical system can accommodate a wider range of equipment. Furthermore, local electrical codes or regulations might impose additional requirements or restrictions beyond those specified in the National Electrical Code. Always check with the local authority having jurisdiction to ensure compliance with all applicable codes and standards. Proper labeling of circuits is also essential for safety and maintenance purposes. Clearly identify each circuit breaker in the electrical panel, indicating the areas or equipment served by that circuit. This will help prevent accidental disconnections or overloads and simplify troubleshooting in the event of a problem. Additionally, regular inspections and maintenance of the electrical system are crucial for ensuring its continued safe and reliable operation. Check receptacles for damage or loose connections, and test circuit breakers periodically to verify they are functioning correctly. Any signs of overheating, such as discolored wiring or melted insulation, should be addressed immediately by a qualified electrician. It is important to clarify some common misconceptions about using 15 amp receptacles on 20 amp circuits. Firstly, it is not permissible to exceed the total ampacity of the circuit, regardless of the receptacle rating. A 20 amp circuit is designed to handle a maximum of 20 amps, and exceeding this limit can lead to overheating and potential hazards. Secondly, using a 15 amp receptacle does not automatically limit the current drawn from the circuit to 15 amps. If a device plugged into the 15 amp receptacle attempts to draw more than 15 amps, the circuit breaker will eventually trip, but the receptacle itself could be damaged in the process. Thirdly, the National Electrical Code does not allow for the installation of multiple 15 amp receptacles on a 20 amp circuit if the total connected load exceeds 16 amps. This is based on the 80% rule, which limits the continuous load on a circuit to 80% of its rated ampacity. In the case of a 20 amp circuit, 80% is 16 amps. In summary, the use of 15 amp receptacles on 20 amp circuits is permitted under specific conditions outlined in the National Electrical Code. Firstly, ensure that no specific loads require a 20 amp receptacle. Secondly, verify that the total load on the circuit does not exceed its rated ampacity. Thirdly, use appropriately rated wiring and overcurrent protection. Fourthly, comply with all applicable local codes and regulations. Fifthly, label circuits clearly and conduct regular inspections. By following these guidelines, you can ensure the safe and reliable operation of your electrical system. Finally, if you are unsure about any aspect of electrical installation or maintenance, always consult a qualified electrician. Electrical work can be dangerous, and it's essential to have the necessary knowledge and experience to perform it safely. Improperly installed or maintained electrical systems can pose a significant risk of fire, electric shock, and other hazards. Always prioritize safety and seek professional assistance when needed. When designing an electrical system, it's also essential to consider the voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code provides guidelines for calculating voltage drop and recommends limiting it to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, use appropriately sized conductors and keep circuit lengths as short as possible. Additionally, consider using higher voltage systems such as 277 volts or 480 volts for long runs of cable. Higher voltage systems result in lower current, which reduces voltage drop. Grounding is another crucial aspect of electrical safety. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing an electric shock. The National Electrical Code requires all electrical equipment to be grounded, and it provides detailed guidelines on grounding methods. Common grounding methods include using a grounding electrode system, such as a ground rod or water pipe, and bonding all metallic enclosures and equipment together. Ground fault circuit interrupters are also essential safety devices. Ground fault circuit interrupters detect small amounts of current leakage to ground and quickly interrupt the circuit, preventing electric shock. The National Electrical Code requires ground fault circuit interrupters protection in wet locations such as bathrooms, kitchens, and outdoor areas. Surge protection is also important for protecting sensitive electronic equipment from damage caused by voltage surges. Voltage surges can occur due to lightning strikes, power grid switching, or other electrical disturbances. Surge protective devices divert excess voltage to ground, preventing it from reaching the equipment. The National Electrical Code recommends surge protection for all electrical systems, especially those serving critical equipment or sensitive electronics. Arc fault circuit interrupters are another type of safety device that detects arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when current flows through an unintended path, such as a damaged wire or a loose connection. Arc fault circuit interrupters quickly interrupt the circuit, preventing the arc fault from igniting a fire. The National Electrical Code requires arc fault circuit interrupters protection in many areas of the home, such as bedrooms and living rooms. Electrical codes and standards are constantly evolving to reflect new technologies and safety concerns. It's essential to stay up to date on the latest code requirements and best practices. The National Electrical Code is updated every 3 years, and it's important to use the latest edition when designing or installing electrical systems. Additionally, consider attending electrical training courses and seminars to expand your knowledge and skills. Electrical safety is a shared responsibility. Everyone, from homeowners to electricians, has a role to play in ensuring the safe and reliable operation of electrical systems. By following electrical codes and standards, using appropriate safety devices, and seeking professional assistance when needed, we can minimize the risk of electrical hazards and create a safer environment for everyone. It's important to note that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult a qualified electrician or electrical engineer for specific recommendations regarding your electrical system. Electrical work can be dangerous, and it's essential to have the necessary knowledge and experience to perform it safely. Remember safety first.